Hello, today we're going to go over hopefully some things that you noticed by doing that activity yesterday in class. And we're also going to be adding in area of triangles and rectangles, which is hopefully something that we are familiar with doing. So our objective today is to calculate the area of a rectangle, calculate the area of a triangle given the height and not given the height. So some things to review. These are the names of polygons. So you can look through this list, and these are names that you're going to want to have memorized and names that you're going to want to know the number of sides for them. So for example, triangle is 3, quadrilateral is 4, pentagon 5, hexagon 6, and heptagon 7, and so forth. So these are the ones you are going to want to know for the test. And once it gets past 12, then they just put the number in front of gon. So an example would be a 40 gon, would have 40 sides. So they put any number that's greater than 12 in front of the word gon. So yesterday, the activity that you were doing was hopefully to help you figure out what the sum of the interior angles of the polygon would be. And doing that, sorry, my one notebook froze. Just got to exit out of it and rejoin it again. There we go. So when you are finding the sum of the interior angles, so that's adding them all up together, the formula for that is S equals n minus 2 times 180. And n represents the number of sides on the polygon. So example 1, find the sum of the interior angles of a polygon that has 21 sides. So right away we know n is 21. And we're finding the sum, so we're just going to plug it into that formula, which is S is going to be n minus 2 times 180. So we're going to replace that n with 21. So then in those parentheses, 21 minus 2 is going to be 19 times 180. So that's what we're going to type into our calculators. So let me pull that up really quick. And we'll take 19 times 180. And make sure you do the subtraction before you multiply. And we would get 3,420 degrees. So that means all of the angles on the inside of a 21-sided polygon is going to add up to 3,420 degrees. And that's true for every polygon that has 21 sides. So if it was a regular polygon, and a regular polygon means that all of the sides, all sides are congruent to each other. It also means that all of the angles are also congruent to each other. So that means every angle inside of the polygon are congruent. If it's not regular, that just means the angles are different measurements and the sides aren't all the same length. So if we were asked to find the measure of each angle inside of a regular dodecagon, we are going to use this formula here. And you'll notice the top part of the formula is the same as the first one we went over when we talked about how to find the sum of all of the angles. So the only thing that's different is once we find that sum, we're going to divide it by the number of sides. And the reason we do that is because each polygon has the same number of sides as it does angles. So for our example 2, what is the measure of each angle in a regular dodecagon? So a dodecagon has 12 sides, which means our n value equals 12. So to find the measurement of one angle, we're going to take 12 minus 2 on top, multiply that by 180, and then divide our answer by 12. So 12 minus 2 is going to be 10 times 180 divided by 12, and we can type that into our calculator. And we're dividing that by 12, and we will get 150 degrees. So this tells us each angle in a regular dodecagon is 150 degrees. So this is each angle's measurement. We can also use this formula to figure out what our n value equals. So example 3 says, if the measure of each interior angle of a polygon is 156 degrees, find how many sides the polygon has. So what we're going to do is we're going to take that formula that we use to find what each individual angle equals, n minus 2 times 180 all over n. And we're going to plug in the information we know. And what we know is that each angle in a regular polygon is 156. So we're going to replace that a with 156. So we have 156 equals n minus 2 times 180 all over n. And the first thing we're going to want to do is to get rid of that n in the denominator. So we're going to start by multiplying both sides by n. When we do that, they simplify on the right side, and we are going to have 156n equals n minus 2 times 180. And because this is a number multiplied by parentheses, we can write it so we have 180 times n minus 2. When we write it like this, you're going to notice our next step, we're going to need to distribute. And when you distribute, don't forget you're multiplying by a negative 2 here. So we have 156n equals 180n minus 360. Now we just have a simple linear equation that we are going to be solving. So to do that, we need all of our n values on the same side. So we're going to subtract this 180n because we already have an n by itself on the other side. So when we do that, if we take 156 minus 180, we're going to get negative 24n. And these simplify, and we just bring down to negative 360. When you do that, make sure you're careful not to forget the negative because that will change your answer. So then our last step is to get rid of this negative 24 in front of the n. We're going to do that by dividing. So we're going to get n equals negative 360 divided by negative 24. And that's going to be positive 15. And that makes sense to get a positive number because we're looking for the number of sides. So for this one, it's going to have 15 sides for our answer. So our next step is to look at the sum of the exterior angles of a polygon. And no matter what the polygon is, no matter how many sides it has, the exterior angles are always going to add up to 360. And this is definitely something you're going to want to have memorized. So we'll star that to memorize that. And the first equation up here, the interior angles, that's something you're going to want to have memorized too. So these three equations, or these three values, you're going to want to know. So because the exterior angles of a polygon always equal 360, we're going to be able to answer some questions based off of that. So example 4, what is the sum of the exterior angles of a 99gon? Well, from what we just read, it's always going to be 360. So even though this one has 99 sides, the sum is going to equal 360 because it says the word exterior here. So then next, in a regular heptagon, what would be the measure of each exterior angle? So something you're going to need to know for this is the number of sides equals the same amount of angles. So if you have 8 sides, that means you have 8 interior angles, and that's also equal to the number of exterior angles. So if you have an 8-sided shape, that means you have 8 interior angles and you have 8 exterior angles. So in a regular heptagon, what would be the measure of each exterior angle? And regular means they're all equal. So we know the total sum is 360. So to figure out what one exterior angle is, we're just going to divide it by the number of sides. And if you look at the table at the beginning, a heptagon means that we have 7 sides. So we're going to take 360 divided by 7. And because this is an angle measurement, it is possible to get a decimal answer. So when this happens, we're just going to round to 4 decimal points again, unless it tells you otherwise. So for this one, it's going to be 51.4286 when we round degrees. And that's going to be the measure of each exterior angle. All right, and our last example for this is if the angles of a pentagon are 22 degrees, 45 degrees, 63 degrees, 100 degrees, and 10x, we're going to find the value of x. So for this, they give us all of the angles inside of the pentagon, which, by the way, has 5 sides, so we know n equals 5. So the first thing we're going to need to do for step 1 is to find the sum of the angles, of the interior angles. And we're not even going to look at the numbers they gave us. We're going to use that formula from the beginning where the sum equals n minus 2 times 180. So we're going to find the sum of the interior angles of a pentagon. And then we're going to use that number to figure out what x equals. So for this, 5 minus 2 is 3, times 180 is 540. So now that we know all together, these have to equal 540, we are going to take that number and we're going to put it equal to the sum of all the angles we know. So we're going to add those together. Plus 100 plus 10x. Now we have an equation we can solve for x. So in my first step, we're going to combine all of these like terms. So we're going to take 22 plus 45 plus 63 plus 100. And that's going to give us 230, and we still have the plus 10x here. And it's equal to 540. Now we need to get x by itself, so we're going to start by subtracting 230. And 540 minus 230 is going to equal 310. And bring down our 10x. And our last step would be dividing by 10. And when we do that, we are going to get x equals 31. And because it's just the value of x, we're not going to have a label on it, so it's not degrees, not inches, or anything like that. It's just x equals 31. Okay. And we're going to do more practice with these tomorrow. So we're going to keep working on them so that we start to memorize those equations that we need to have memorized. And the next part is talking about the area of a square, rectangle, parallelogram, and triangle. So hopefully all of these are familiar to you. So the area of the square is just the side length squared, or you can take the side length times the side length. Area of a rectangle is base times height. Area of a parallelogram is also going to be base times height. One thing about this though is you need to be careful when you're looking for the height because it's not going to be that second side length like a rectangle. It is going to be a line that is perpendicular from one base to the other. And lastly, the area of a triangle, which we've done before, is area equals 1/2 base times height. And we did a lot of those last chapter, so hopefully it is familiar with you on how to find the area of those triangles. So when you're finding the area, the first thing you're going to want to do is identify what formula you're using. So for this one, this is a parallelogram because the sides are parallel to each other. So we're going to use the base times height. So the shaded region A, B, C, D, that is what we're finding the area of. This 4 on the outside, that is representing our height. So our formula is area equals base times height. Our base length is just going to be one of these that is going the opposite direction of the height. So that's going to be 9. So area equals 9 times 4, which is 36. And when you do this, you're always going to have units squared for area. This one doesn't give us a unit, so I'm just going to write units squared. Our next one, we're going to find the area of the triangle. And area is equal to 1/2 base times height. So for this one, it's going to be 1/2 multiplied by our base. And when you find the base, make sure you're doing the full length. So this one, we're going to have to add 45 plus 21, which will give us 66. So that's going to be our base. Then we're going to multiply it by the height, which they give us in this one, of 28. Then we can just type this into our calculator, and when you type in 1/2, you can do 0.5 or 0.5. And instead of parentheses, you can just use the multiplication button if you would like. So for this one, it's going to be 924 units squared. Oops, that's supposed to be a 2. There we go. And hopefully that's not new information because we have found the area of a triangle before. Example 9, the base of a triangle is 4 times its height. So let's draw a triangle. The base, which is this length down here, is 4 times its height. So if we have our height here, the base is 4 times that length. So we're going to put 4h on the bottom. Next, they tell us the area of the triangle is 50 square inches. Find the base and the height. So there should be a comma here. So in our area formula, we know area of a triangle is 1/2 base times height. And they told us that the area was equal to 50 square inches. So we're going to replace the A with 50. And 1/2, the base was 4h, and the height was just h. Now we can start simplifying. So on the right side, we're going to start by multiplying all of this together. So when you do that, you're going to multiply the number values. So 1/2 of 4, which is 2. And then you're going to multiply the variables, h times h, which would be h squared. Then we need to isolate the variable, so we'll divide both sides by 2, which will give us 25 equals h squared. And just like with Pythagorean theorem, to get the h, so we just have 1, we're going to take the square root. And the square root of 25 is 5. And normally you'll get 2 answers when you take the square root, plus or minus, but because this one is a length, we are just going to be using the positive value. So our height is going to be equal to 5 inches. So then our base, which is equal to 4h, would be 4 times 5. Our base is going to be equal to 20 inches. So once you set up the equations, you can just go ahead and solve. Our next one, we're going to find the area of this shaded shape below. So you'll notice this isn't one of our shapes because there's multiple here. So we're going to cut it into 2 rectangles, or a rectangle and a square. So because these are perpendicular to each other, this 5 over here is going to be the same length over there. So it's going to be 5 straight across from it. And if we know this full side length is 9, and we already have used 5 of it, that leaves 4 left to be the top part. So to find the area of the yellow shaded region, we are going to take 9 times 4, and then we are going to add the area of this purple shaded region. So we're going to do plus 5 times 5, or you can just write 5 squared if you'd like. And that'll give us the total area of those shaded regions. So we can just type that into our calculators, 9 times 4 plus 5 times 5. Oops. 5 times 5. There we go. So we're going to get an area of 61 meters squared. So you just need to divide those shapes up into objects where we know the area formula and then add them together. And our last example, a parallelogram has an area of 133 feet squared and a height of 19 feet. What is the length of the base? So again, the area formula for a parallelogram is base times height. So we're going to fill in the information we know. They told us the area is 133 feet, so we can plug that in. And they also told us that the height was 19 feet. That was the height, so we can plug that in for height. And we just need to figure out what the base is. So we're going to divide both sides by 19. So 133 divided by 19. And we will get 7 is equal to the base. And don't forget your labels for your units. So this is going to be 7 feet. So your homework today is going to be on finding area of these different shapes. And it's going to have problems similar to what we went over in the first 4 examples as well, or first 6 examples. And we will go over those again tomorrow if you have questions. So if you're confused on them right away, try them on your own and then ask questions tomorrow at the beginning of class. I will also get an answer key posted for you later today. So if you have any questions, let me know.